Hi everybody, thank you for being here. I'm Koustuv Saha, and along with my co-primary author Ted Grover, we are delighted to present our work on building person-centered prediction models of psychological constructs with social media contextualized by multimodal sensing. We first thank our co-authors Steve, Vedant, Pranshu, Gonzalo, Pablo, Gloria, Aaron, and Munmun. Now, before I begin, I would like to set the stage for social media as a passive sensor. Social media platforms enable us to share our thoughts and connect with others. And this has enabled researchers to leverage social media as a passive sensor to examine and predict human behaviors and well-being. And social media data is self-recorded in a self-motivated fashion in one's naturalistic setting. And this data can be collected unobtrusively to obtain longitudinal and historical data beyond study periods. Social media alternatively functions as a verbal sensor as it can capture people's linguistic expressions. So while we saw some of the potentials of social media data, it also comes with limitations. Like even though social media data can be collected passively, it is dependent to be actively curated by the individuals. Social media data is sparse and not everyone is equally active on it. And again, people's social media behaviors have offline underpinnings. And complementary multimodal sensing can contextualize offline behaviors, which could address the limitations of social media and help us obtain a holistic understanding about an individual. And in this work, we leverage multimodal offline sensing to contextualize person-centered predictions. So typically, we build social media-based prediction models on the entire dataset that we have. However, social media use and language may tremendously vary across individuals. Now, while this challenge can be overcome through personalized models, social media data also suffers from sparsity issues. And therefore, in this work, we balance the trade-offs between two personalized and two generalized models by contextualizing on offline behaviors as captured by multimodal passive sensing. So if you see the bottom figure on the contextualized approach, we built separate models of behaviorally similar individuals to predict the psychological constructs. These models can effectively capture between individual homogeneity and within individual heterogeneity in our behaviors. And my co-primary author Ted will take from here on and explain the methods, results, and implications of our work.
Thank you, Koustuv. In our work, we collected data from 754 information workers. As part of the onboarding process, participants were required to complete ground truth surveys that gathered scores for various psychological construct measures. Passive sensing data from these participants was collected continuously for a year-long period. Offline and physical activity data was collected through a variety of different sensor modalities, and social media data from participants' Facebook accounts was also collected. From the passive data collection, we generate a variety of different behavioral features. For the physical sensor data, we compute features for the mean, standard deviation, and regularity in daily behavior. To build our contextualized models, we use these offline sensor features to cluster participants based on differences in their offline behavior. We tested 3 different types of clustering algorithms and evaluated these clusters based on 3 different metrics of cluster fit. Across all clustering fits tested, we found that hierarchical clustering with 3 clusters was most optimal. We evaluate all modeling approaches using a 5-fold cross-validation framework and evaluate performance in terms of pooled Pearson's correlation and SMAPE across all training folds. We test several different machine learning algorithms and also withhold a separate testing set of 50 participants to evaluate the robustness of any performance trends on unseen data. The figure here provides a summary of predictive performance results and the differences in performance for generalized versus contextualized modeling approaches. We found that the contextualized approach yielded increased performance in predictions of personality traits, anxiety, and sleep quality, but decreased performance for cognitive ability. These patterns of results were also consistent for the held-out testing data set. The figure here presents pooled Pearson's correlation results comparing different modeling approaches, including models built solely from sensor data as well as sensor and social media feature sets combined. The contextualized modeling approach, shown as dark blue in this figure, performed significantly better than these alternative modeling approaches for most personality traits, anxiety, and sleep quality. Overall, there are a few key implications of our work that should help future research in this domain. First, there are important trade-offs between generalized and contextualized models. More data in a generalized modeling approach may not always be best, as contextualized models built on smaller participants pools per cluster perform better for some constructs. Second, our work has implications for when to invest in building more personalized models. Contextualized modeling approaches may be better suited for constructs that have a stronger theoretical association with physical behavior. Finally, contextualized modeling approaches may also allow for more precise insights into multiple online and offline behaviors associated with psychological constructs. This concludes our presentation. Thank you for watching, and feel free to reach out to either Koustuv or myself with any questions you may have.